Hiya, this is Andrew, and today we'll go over the May 26 Time Zone C Paper 1 for SL. At first glance, this paper looks very manageable. No big surprises, we could all see this coming. There's still some elements here and there, but by and large, I would say you don't need to get more than 60 out of 80 to get a 7. Without any further ado, let's get started with question 1. So this is a freebie. 1A. Find the number of grade 12 students in the sample. So, a school has 600 students, 170 of them are from grade 12. We need to get a group of 60 using a stratified sampling technique. Okay, in other words, we need to find the number of grade 12 students so that it is representative of the school's population. The school has 170 grade 12 out of 600. In our sample of 60, we would need 17. B. Now we have a box plot. State the median right there staring back at you, 80. The interquartile range is 24. Okay, so A minus 66 is 24. A is equal to 90. Done. Determine the smallest possible allowance that is not an outlier. Okay. So, what would be the upper and the lower bounds for the outlier? The lower bound would be 66 minus 24 times 1.5 or 30. The upper range would be, oh, we need the smallest possible allowance, so $30. That's it, we're done. Branded easy question. Question 2. We have a triangle ABC. AB is 5, BC is 6, cos ABC is 1/5, ABC is acute. Find AC. Wow, okay. Mind blowing. So, you know we have to use the cosine rule. AB is 5, BC is 6. Cos ABC, that is 1/5. And this will give us 49. Thus, AC is equal to 7. Part B. First, we need to find sine of ABC. Okay, so sine of ABC is going to be the square root of 1 minus cosine squared of ABC. Now, we take the positive square root because we know ABC is acute. It's in the first quadrant, sine has to be positive. Two root 6 squared, that's 24. Oh, sorry, 1 minus 1 over 25. This will give you square root of 24 by 25, or square root of 24 divided by 5, or 2 root 6 divided by 5. Hence, find the area of a triangle. Okay, so that's going to be a half times AB times BC times sine of ABC, and this will give you 6 root 6 centimeters squared as your final answer. This is a very friendly starting question as well, because all of these three parts are actually independent of one another. Question 3, binomial expansion. Okay, now we're talking. The coefficient of x cubed is 8 times the coefficient of x squared. Okay, we'll need to use that for part B. Part A, show that 8C3 is 56. So using the definition, this is equal to 8 factorial divided by 3 factorial 8 minus 3 factorial. In other words, 8 factorial divided by 3 factorial times 5 factorial. So 8 times 7 times 6 times 5, 4, 3, 2, 1. Downstairs, we have 3 times 2 times 1 times 5, 4, 3, 2, 1. They can all be cancelled out. 6 will cancel with 3 and 2. So you are left with 56. The fact that it is 1 mark means that it should not be too hard. Part B. The coefficient of x cubed. How do we get the coefficient of x cubed? That would be 8 chooses 3 m cubed. How do we get the coefficient of x squared? That would be 8 chooses 2 m squared. 8 chooses 2, that is 28. So therefore, 56 m cubed is equal to 28 m squared. Therefore, swap it to one side and factorize. M is equal to 0 or m is equal to 1 by 2. We would take m equals to 1 by 2 because m is strictly positive. Pretty straightforward question as well. But I'm sure this part will catch a couple students off guard. Question 4. P and R are positive integers greater than 1. Okay, part A. We need to simplify the right-hand side. So, 3 plus log base 3 of R. 3 is log base 3 of 3 cubed. Now we just need to add two logarithms of the same base. We multiply the arguments. This is equal to the left-hand side, thus P is equal to 27R. Part B. Hence, find the value of R and the value of P. Okay, from the second equation, we can deduce that P is equal to R to the 4. Part A shows that P is equal to 27R, thus R to the 4 has to be equal to 27R, and therefore R is equal to 0 or R is equal to 3. We know that R is a positive integer greater than 1, so cannot be equal to 0. If R is equal to 3, then P is equal to R to the 4 or A to 1. Hence, P equals A to 1, R equals to 3. Question 5. Part A. Differentiate this guy. This is quite straightforward. You will get 4x cubed minus 4 cos of 4x. This 4 comes from the chain rule. Part B. Hence, find this integral. 1. They tell you to use hence or otherwise. Never ever go for the otherwise option, especially when they give you part A. And you notice that this probably has something to do with this. So let's just do a u sub, shall we? If u is x to the 4 minus 4 sine minus sine 4x, u prime is equal to 4x cubed minus 4 cos of 4x. Right? This means that your integral would now become the integral of 1 by 4 u to the 7 du. This will give you 1 by 32 u to the 8 plus c. So now you only have to copy everything back into the expression to get the final answer. Question 6. Part A. Find an expression for the inverse of x. Quick recap, this is the inverse, not the reciprocal. Okay, so to find the inverse, first you replace y with x and x with y. So I'm going to start with x equals to 4 minus 7 divided by this. And now your job is to isolate this guy. So bring it over. And now we can isolate for the inverse. They did not specify the form. I'm going to keep my answer as is. Part B. Now this is the trickiest part of the question, of the entire section A. Using your answer to part A or otherwise, find an expression for g of x. This is quite tricky. I would start off by applying the inverse of f to both sides of this equation. F minus 1 and f, that will give you x, aka there will be no changes at all. Therefore, g of x divided by 3 is equal to the inverse of f that you have just found previously. From here, how do you find g of x? To find g of x, you're going to replace x with 3x. So use your answer for the previous part, bring it back down, then replace x with 3x, and you're good to go. This is a tricky question, don't get me wrong. So heads up if you manage to solve this correctly.